commonly tested in the final exam. Please take note. If they don't give you the 5 steps you learn, p-value is normally there. What is a p-value? What is the understanding of a p-value in hypothesis testing? What is a p-value in what? In hypothesis testing. Right, p-value refers to, this value refers to how much this value refers to how much alpha can increase or decrease before rejecting HO. How much alpha can increase or decrease before rejecting HO? To what extent can your alpha increase or decrease before rejecting HO? This is what we are trying to do under p-value. It is a concept that you must understand in order to again decide whether to accept HO or reject HO. To accept HO or reject HO in your subject, there are 2 ways to do it. One is to run your 5 steps. The other way to accept reject is to do a p-value. And what the subject says is, if for example, based on your 5 steps, you do this, you make a decision. If you run with alpha 5%, one-tail test, you will get one tail on the right tail, for example. 5% one tail, what is your reading, please? 5% one tail, what is your reading, please? 1.645. If this is a 1.645, then any answer that falls in the shaded region, you say reject. Clear region, accept. If your calculated test statistic Z, we call it the Z, calculated test statistic Z equal 1.5. You finish putting the formula, you got 1.5. If your answer is 1.5 falls in what area? Clear area. If it falls in a clear area, you say accept HO. So p-value asks the question in another way. How much must alpha increase before rejecting what? HO. Now you're saying accept HO, right? With 5% you're saying accept HO or reject HO? Accept. So if you want to increase, if you want to reject HO, the alpha must get larger. The alpha must get larger until you reach 1.5, correct? If your alpha reaches 1.5, you will reject HO. So if I shade the new area now in red, the red shaded area is known as what value? P-value. So what is a p-value? P-value is changing the alpha in order to reject what, please? HO. If you're accepting HO, then your red shaded area is larger than the black shaded area. Agreed? Agreed. Listen carefully because it's a very technical concept. You got to understand the simplified version. It's not an easy concept. Please listen. So the red shaded area is called the what value? P-value. And the logic in doing this p-value is, as long as p-value is greater than alpha, as long as your p-value is greater than alpha, your decision to accept HO is perfectly correct. We confirm that decision by calculating a p-value. So if the p-value exceeds the alpha, accepting HO is perfectly correct. But if your p-value is lower than alpha, guideline given under p-value, if p-value is lower than alpha, then you should reject HO. Greater than alpha, you accept HO. Lower than alpha, you reject HO. That is the understanding behind a p-value. Like in this case, if I take this example, go to your normal distribution table, please read 1.5. If you read the reading for 1.5 in your Z table, please check your Z table. All of you have your Z table. In your Z table, if you check 1.5, 1.5 equal to, reading for 1.5 equal to, what is your normal table? What is your reading for 1.5? We want to find a p-value. P-value, you read your test statistic calculated 1.5. At 1.5, p-value is equal to 0.5 minus reading of 1.5, please. You want the whole thing, right? To get the whole thing, read 1.5 is 0.4332. 0.4332 is from here to here, right? So you want the whole tail from here to here is 0.5 minus 0.4332. The reading of p-value is 0.0668. Yes, no. If p-value is 0.0668, this is greater than 0.05. And because 0.0668 is greater than 0.05, your decision has to be what? Accept HO. So a p-value is another way of deciding accept HO and reject HO. P-value is another way of deciding accept HO and what? Reject HO. That is the concept of a p-value, which brings you to the second way of deciding accept, reject. If you don't run your 5 steps, they can test you accept, reject through p-value. You must know the conditions in p-value to accept and reject. If I take another example, if I take another short example before we look at more difficult things. This is now again 1.645. This is 1.645, you shade. Then you calculate your Z. If you calculate your Z, you will get, if you calculate your Z, let's say you get 1.8. If you get 1.8 for your Z, this means you are in which area? You calculated your Z, you got 1.8. 1.8, you're in the shaded area. Shaded area means your decision was reject HO. Can we confirm this by p-value now? If you reject HO, then your p-value logic is like this now. You don't need such a big alpha. A smaller alpha would have rejected HO, yes or no? Yes or no? What should that small alpha be? That is called the p-value. So the red shaded area is p-value. The entire black shaded area is alpha. So if you go back to the table and read, this red shaded area refers to what value, please? P-value. How to get the p-value? Again, read 1.8. If you read 1.8, you will get 0.5 minus, reading of 1.8 please, 0.4641. If you minus 0.4641, this will give you 0.0359. Is it? If this is 0.0359, then you come to alpha. Alpha will be 0.05. Alpha is 0.05, p-value is 0.0359, which is greater? Alpha is greater. If alpha is greater than p-value, confirm your decision to reject HO is perfectly correct. So as long as p-value is smaller than alpha, reject HO. P-value greater than alpha, accept HO. Next style of deciding in hypotheses. And another way of interpreting the p-value is, you know, shaded area also represent probability, right? You know, shaded area also represent probability, right? First topic you learn in sampling theory is probability, right? So whenever you do probability, do you shade or not? Yes. So probability, another way of interpreting, one way of interpreting is p-value refers to how much alpha can increase or decrease. After you understand the logic of making a decision, another way of seeing p-value is this. P-value is also defined as the probability of obtaining, alright, this is another way to see p-value, please. P-value can also be defined as the probability of obtaining sample mean or X bar above or below is the probability of obtaining sample mean X bar above or below a given value. This is the probability of obtaining sample mean X bar above or below a given value. Is also known as what? Is also known in statistics as p-value. So whenever you're asked to interpret p-value, they will fix it together with what? With a problem and ask you to estimate the p-values. If you come back to the same example just now, the insurance charges question, follow? If you come back to the same question just now, which is the insurance charges question, there is one more part in that question. Find a p-value for these hypotheses which you have. Got it? The same insurance question. Find the p-value for these hypotheses and sample proportion PS in part A. Use the p-value to choose between the two hypotheses. If I take back the same working I did the first question opening today, can we find a p-value? Yes, we can. How? Go back to the hypothesis in front of you and part A, please. If you go back to part A, how do we find a p-value for these hypotheses? Right? Get a p-value for the hypothesis and the sample proportion PS in part A. Use the p-value to choose between the two hypotheses. Got it? Okay, how do you choose this hypothesis? Okay, logic is very simple. Please follow. To choose between the two hypotheses, all you need to do is go back to what you have just now. What is p-value? It is the probability of obtaining sample mean X bar, if it is X bar, p hat if it is proportion, above or below a given value. So, if I go back to the first part of this question, if you remember, right here, first part we made a decision, accept or reject. First part decision was accept or reject. Accept what? HO. If you accept HO, that's because you're in which region, please? Clear. So we accept that. Now the question is, what is the p-value? P-value means your alpha you chose was how many percent in the first part? Alpha you chose in the first part was how many percent? 5. So p-value must go until the calculated value, which is 1.3, right? So what is the p-value? If I take out this diagram and put it back here, if I take out the diagram from the first part and put it back here, all I need to do is this. Bring the diagram inside, go back to part A, copy back this diagram.